What does it mean to be congruent? If-then statements. If congruent segments, then what?
Angles.
If congruent segments, then what?
Same length.
Equal lengths. If congruent angles, then, did I say segments? Then equal measures, right? So when we're talking about congruent segments and congruent angles, we're talking about their measurements being equal. When we're talking about congruent figures, we need to have equal measures. So congruent figures are when two figures have the same angle measures and same side lengths. Okay, so for me to have something being congruent, all the angles need to be the same between the two shapes, and all the side lengths need to be the same between the two shapes. Now the next definition, it brings up the word corresponding. If you think back to chapter 3, we're talking about corresponding angles. What did that mean? They're kind of in the same position, right? So upper left, upper left. The same thing kind of applies when we have congruent figures. We have corresponding parts. So corresponding parts are matching parts of congruent figures. Throw a period there. So when you have corresponding parts, you're going to have corresponding sides and angles. So there are corresponding sides and angles. All right, so when we're talking about congruency, we need to be able to pick out these corresponding parts, and we need to be able to write what's called a congruence statement. We're going to do both in the next example. All right, so example 1 tells us to write a congruence statement for the triangles given, and then identify all pairs of congruent corresponding parts. So the first thing I'm going to do is write a congruence statement. Well, you have been writing congruent statements already in your proofs. Don't write this, just watch. You would do something like line segment AB is congruent to line segment DC, right? You did that before. Or you said angle A is congruent to angle B. Well, that's a congruent statement. You're stating what geometric figures are congruent to each other. Well, now that we're getting into triangles and talking about triangles being congruent, I'm going to write a triangle congruent statement. So this is how we're going to do it. I'm going to name this triangle. Doesn't matter what order I pick. I'm just going to happen to go A, B, C. So I'm going to say triangle A, B, C. Okay, whenever we're naming a triangle, we put a little triangle in front of the 3 letters that make up the triangle's vertices. If it's anything larger than that, you just list the letters. So if it was a quadrilateral, you would just list all 4 letters. You don't put a little quadrilateral symbol in front. All right, so now triangle ABC is going to be congruent to triangle. Now this is where it is super important that you have your matching parts in the same position in your congruent statement. Notice angle A is a right angle. What's the right angle over in the other triangle? F. So if I'm putting A first, then I should put F first over here. Yeah. B has 1 congruent marking. G has 1 congruent marking. So I'm going to put G next, followed by H. That is a congruence statement. So if you're asked to write a congruent statement, it should look like that. It is very, very important that your letters match up with each other. Raz.
Why couldn't it be GFH?
Why could it not be GFH?
Yeah.
Because here A is my right angle, and
Yeah.
F is the right angle over there. That's why A and F need to be in the same spot. If I reordered it, don't write this, just watch. If I reordered it to triangle CAB, what would be the order of the triangle for the second one? So C matches with H, A would be F, and then G, right? So you got to make sure that the orders are matching up.
You could
Yep, you can put it in whatever order. If I did triangle BAC, what would be the second triangle? So B matches up with G, A is F, and then H, right? Those would all be correct answers.
Alright, yeah, I was just confused a little bit, but I got it now.
Okay, good. All right, so now the next thing we're going to do is identify all the pairs of congruent corresponding parts. Since it is a triangle, how many sides does a triangle have? 3. So I'm going to have 3 corresponding sides, and I have 3 angles, so I'm going to have 3 corresponding angles. So let's do our sides first. Now, the beauty of having a congruent statement is once I have this and I know that it is correct, I don't even have to worry about the diagram anymore. Okay, and I'll show you why. If I look at my first 2 letters and combine them together and turn that into a side, I could call that side AB or line segment AB. Notice in my diagram, line segment AB has 2 tick marks. Which side over on the other triangle has 2 tick marks? Yeah, so now we got to make sure the order is correct. If I'm going AB, first two letters would be FG. So line AB is congruent to side FG. Notice FG has my 2 markings. It would be incorrect to write GF, because then you don't have your corresponding parts matching up. Okay? Now let's do the last 2. BC. What would BC match up with? BC, GH. Again, if we look at the diagram, BC has 3 tick marks. GH has 3 tick marks. What's the third side that I'm missing? AC, good. So if we do AC, that would pair up with FH. Good. Okay. If I would have said CB, what would that match up with? HG. If I would have said CA, that would have matched up with HF. And if I would have said BA, then it would have matched up with GF. Good. All right, so there are your 3 sets of corresponding sides. Now let's do the angles. What's nice about this diagram is none of the angles are connected or adjacent to each other, so I can just use a single letter to name them. So angle A would be congruent to angle what on the other side? F. Good. Notice A and F are the first letters in our congruent statement. Angle B would be congruent to, good, angle G. And angle C would be congruent to H. Good. Done. Okay. So on the quiz on Friday, you might be given a congruent statement, and you might be given the left side, and this might be a fill-in-the-blank question. Well, AB is congruent to what? And you would have to be able to fill it in. Would you be able to do that? Hopefully. Hopefully you remember, just know how to do that. All right, so on to the next example. Now they're giving us a congruent statement. We no longer have triangles, we have quadrilaterals. That's why there's no symbol in front of my letters. And I need to solve for x and I need to solve for y. So it's telling me that these 2 quadrilaterals are congruent to each other. Let's first focus on x. I see an x here in this expression, and I see an x here in this expression. The y minus x I'm going to ignore for now because it has a y in it also, and I can't solve for it because I have 2 unknowns. So let's focus on this x right here at the 5x plus 5. Is that inside an angle or a side length? It's in an angle. Which angle? W. Now jump up to your congruent statement. W matches up with what on the other side? Q. So now look at the actual diagram. What is Q's degree? 65. So because they are congruent, that means they have equal measures. So 5x plus 5 should equal 65. Solve it. So subtract 5 gets you 5x equals 60. Dividing it gets us x equals 12. Now we need to find y. So now let's go over to our diagram. Here I have a y minus x, but we just said x is what? 12. So now that just turned into y minus 12 inches long. So is it an angle measurement or a side measurement?
Side.
A side. Which side?
X.
WX. All right, so now let's go up here. WX is the first two letters. So that would match up with QR. What's QR's length? 6. So because they are congruent, that means that they are equal. So 6 equals y minus 12, which means y is equal to 18. Good. Okay.
Do they really always add up to 180?
The angles inside, yes. The interior angles, yes.
Like no matter the size of the triangle?
Correct. Yep, no matter what. Okay. All right, once you have that, flip onto the back so I know you're ready. All right, so now we're going to introduce a theorem, which is called the third angles theorem. It's quite long, so feel free to abbreviate any of these words into symbols. Your third angles theorem states if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. I would put a star next to that and say maybe note of putting that onto your blue reasons for proof sheet. That's a nice one to have memorized. Well, not memorized, on your sheet. So when we get to our proofs later in the chapter, you might want to use it.
Wait, so,
So let's make sense of this. Okay? Don't put these numbers in, just watch. I'm going to just make up some numbers. Let's say, for example, that B was 90 degrees and A is 60 degrees. So if A is 60 degrees, what is D? 60. Why do I know that? Because they're congruent. What would be E? 90. What would be C? 30. What would be F? So is it true that C and F are also congruent? Yeah. So this is the third angles theorem. So if you got two sets of congruent angles, then it must follow suit that the third set will also be congruent. Okay? That's your third angles theorem. And the reason why you might want that is if you need to try to get congruent angles, you could use that. All right, so let's look at this diagram here. We need to find the measure of angle V. So let's start filling in what we do know. Here I have a 66. Here I have a 44. What would S be?
22.
So 66 plus 44 is 0, 110, 180 minus 110 puts us at 70. So S is 70 degrees. Here I have one set of congruent angles on each of these triangles. I have a second set of congruent triangles right here because of vertical angles. So if I've got two sets of congruent angles, what should be true about the third set? They should be the same. So the measure of angle V would be what? Good. If you did not remember the third angles theorem, that's okay. You can get there just by knowing that my vertical angles are the same. I see a congruent mark, so that means if that side's 66, then this side has to be 66. And then we could have done the same arithmetic to get to the 70 there. Okay? All right, so we're going to finish with a proof. Again, you're not going to need to do a proof on your homework. You're not going to need to do a proof on your quiz on Friday. This is just good review of how we do proofs. So I like what Camille's already doing, which is setting up her T-chart. She's putting her statements on the left, reasons on the right. Always start with the given. Now notice we have a whole lot of given there, so I'll give you a second to get it all jotted down. So AD is congruent to CB, DC is congruent to BA, angle CACB is congruent to angle CAB, angle CAD is congruent to angle ACB, given. All right, so what did we write about our definition of congruent figures on the front page? What's true about congruent figures?
Have the same angle, measures in same side.
So they're going to be congruent if all of the measures are the same. So all the sides have the sides, same side length, all the angles have the same angle length. We are trying to prove that triangle ACD, the ACD is the one on the left, is congruent to angle CAB, which is the one on the right. In order to be able to prove that they are congruent, I need to show in my proof all 6 of the corresponding parts shown congruent. So off to the side here, let's just quickly show all of the corresponding parts. AC, so quick refresher, AC would be congruent to what? AC would be congruent to CA, is one of my sides. CD would be congruent to what?
AB.
AB. And AD would be congruent to CB. Good. Now let's do my angles, because they have more than one letter. I'm going to use all 3. So angle ACD would match up with what? CAB. Now I'm going to reorder. Angle CDA would match up with ABC. And angle DAC would match up with, so DAC, BCA. All right, so which ones are already checked off in my given? I see an AD and a CB, so that one's checked. I see a DC and an AB, which is the same thing there, just reordered. Okay, so I'm missing this one. Now let's go to the angles. I have ACB and CAB. Hold on, do I have this written wrong? Yeah, I think the D. I was going to say, that does not look right.
ACD.
Yeah, so ACD and CAB, or CAB's good. And then we have a CAD and an ACB, which is my last one, just reordered. So I'm missing that one. All right, so how am I going to get those in there? Well, what theorem can I use to get the third angle shown congruent? Which theorem can I use to show that the third angles are congruent? The third angles theorem, right? So let's go ahead and do that. So line 2, let's put angle CDA is congruent to angle ABC. All theorems should be written if-then form. Yes, it would be so easy just to write the third angles theorem, but we're going to write it out. So if 2 angles,
Did you just say third?
I just said you have to write it out in if-then form. That was what the math department decided is going to be the law. Theorems will be written in if-then statements. So if 2 angles congruent to 2 angles in other triangle, I'm just paraphrasing here. So if 2 angles congruent to 2 angles in other triangle, then third angles congruent. That would work. It's pretty lazy. You're welcome to put that laziness in your blue sheet if you want to abbreviate and paraphrase the actual whole theorem itself. All right, so now I've got my 1, 2, 3 sets of corresponding congruent angles. How am I going to get this last side? Go look at the diagram. What is true about AC and CA? It's the same thing. So what property tells me that something is congruent to itself? The reflexive property. That's going to get used a whole lot in this chapter. We were using the transitive property a lot in chapter 3. We're going to be using the reflexive property a lot in chapter 4. It's going to become your best friend. So reflexive property. Oops. Reflexive property.
What's an example of the transitive property again?
If A equals B and B equals C, then A equals C. Okay, so my last line should always be what? The actual prove line. So line 4 should say triangle ACD is congruent to triangle CAB. Right now our reasoning is if all corresponding parts are congruent, then figures are congruent. You do not need to memorize that because you're not going to need to do a proof for section 4.2. So do not star that and do not put that on your proof sheet of paper. That is a waste of space.
So we're not doing proofs this section?
Not this section, correct.
Are
Yeah.
we gonna do any again?
Yeah, the whole rest of the chapter is proofs.
Algebra stuff that we're gonna do? That's next.
A little bit here and there. Okay? All right, any other questions with that?